Thunderstorms are among the most dramatic and fascinating weather phenomena on Earth. They are characterized by the presence of lightning, thunder, heavy rain, and sometimes hail. Thunderstorms can vary in size and intensity, from small, localized events to massive, system-wide storms that affect large regions. This video delves into the scientific mechanisms behind thunderstorms, their formation, and the weather patterns that lead to their development. We will also explore some intriguing facts and data about these natural events. Welcome back to Resources for Life 101, the small channel with big ambitions. Thunderstorms form when warm, moist air rises into cooler regions of the atmosphere, leading to condensation and the release of latent heat. This process can be broken down into several key stages. Cumulus stage. In this initial stage, warm air rises and cools, causing water vapor to condense into tiny droplets. This forms a cumulus cloud which continues to grow as long as warm air is supplied from below. Mature stage. The cloud reaches a height where ice crystals and supercooled water coexist. At this point, updrafts, rising air, and downdrafts, descending air, coexist, leading to the development of heavy rain, lightning, and thunder. This is the most intense phase of a thunderstorm. Dissipating stage. Eventually, the supply of warm air diminishes and downdrafts dominate. The storm begins to weaken and precipitation tapers off. Updrafts and downdrafts. Strong updrafts are essential for the development of thunderstorms, as they carry warm, moist air upwards. Downdrafts, on the other hand, bring cooler air and precipitation down to the ground. Latent heat. The release of latent heat during condensation fuels the storm, providing additional energy to sustain and intensify the updrafts. Instability. Atmospheric instability, where warmer air is situated beneath cooler air, is crucial for the development of thunderstorms. This instability allows air to rise rapidly, forming the characteristic towering cumulonimbus clouds. Moisture. High humidity levels provide the necessary water vapor for cloud formation and precipitation. Single-cell thunderstorms, also known as pulse storms, are small and short-lived, typically lasting less than an hour. They often form in environments with weak wind shear and are usually not severe. These storms are common in the summer months and can produce brief, heavy rain and occasional lightning. Multi-cell thunderstorms. These consist of multiple single-cell storms at different stages of development. They can produce more significant weather impacts, including stronger winds, larger hail, and more intense rainfall. These storms are often organized into clusters or lines known as squall lines and can last for several hours. Supercell thunderstorms. These are the most intense and dangerous type of thunderstorm. Characterized by a rotating updraft known as a mesocyclone, supercells can produce severe weather, including large hail, damaging winds, and tornadoes. They require strong wind shear and significant atmospheric instability to develop and can persist for several hours. MCSs are large, organized groups of thunderstorms that can cover hundreds of miles. They often form in the later afternoon or evening and can last well into the night. MCSs can produce widespread severe weather, including heavy rain, flooding, strong winds, and hail. Please consider a like and subscribe to our channel and help us grow to keep bringing you good, interesting, and helpful content. Thank you. Back to the video. Thunderstorms often form in regions where warm, moist air masses prevail. These conditions are commonly found in tropical and subtropical regions, especially during the summer months. In these areas, daytime heating can cause the air to rise and form thunderstorms. Cold fronts. A cold front occurs when a mass of cold air moves into an area occupied by warmer air. The cold air forces the warm air to rise rapidly, leading to the formation of thunderstorms. These storms are often intense and can produce severe weather, including heavy rain, hail, and strong winds. Warm fronts. A warm front occurs when a warm air mass moves into an area occupied by cooler air. The warm air gradually rises over the cooler air, leading to widespread cloudiness and precipitation. While thunderstorms associated with warm fronts are typically less intense than those with cold fronts, they can still produce significant weather. Convergence zones are areas where winds from different directions come together, forcing air to rise. These zones can lead to the development of thunderstorms, especially in tropical regions where the Intertropical Convergence Zone, ITCZ, is located. The ITCZ is a region near the equator where trade winds converge, leading to frequent thunderstorm activity. Orographic lifting. This occurs when air is forced to rise over a mountain range. As the air rises, it cools and condenses, forming clouds and precipitation. Thunderstorms can develop in areas where moist air is lifted over mountains, particularly on the windward side. Lightning is a powerful electrical discharge that occurs within a thunderstorm. It can occur within a cloud, between clouds, or between a cloud and the ground. The process of lightning formation involves the separation of positive and negative charges within a storm cloud. This separation creates an electric field, which can become strong enough to overcome the resistance of the air, resulting in a lightning strike. Lightning can reach temperatures of up to 30,000 Kelvin, 53 to 540 degrees Fahrenheit, making it hotter than the surface of the sun. The intense heat causes the air to expand rapidly, producing a shock wave that we hear as thunder. Thunder is the sound produced by the rapid expansion and contraction of air surrounding a lightning bolt. The sound of thunder can vary depending on the distance from the lightning strike and the characteristics of the storm. Close lightning strikes produce sharp, loud claps of thunder, while distant strikes create a low, rumbling sound. Thunderstorms can produce intense rainfall in a short period, leading to flash flooding. This occurs when the ground cannot absorb the rain quickly enough, causing water to accumulate rapidly. Flash floods are particularly dangerous because they can develop with little warning and have strong, fast-moving water. Hail. This forms within thunderstorms when updrafts carry raindrops into extremely cold regions of the atmosphere. These raindrops freeze and accumulate layers of ice before falling to the ground. Hailstones can range in size from small pellets to large golf ball-sized chunks. Large hailstones can cause significant damage to crops, vehicles, and buildings. Tornadoes. These are violently rotating columns of air that extend from a thunderstorm to the ground. They are most commonly associated with supercell thunderstorms, but can also form in other storm types. Tornadoes can cause widespread destruction, with wind speeds reaching over 300 miles per hour in the most severe cases. Thunderstorms can also produce strong, gusty winds known as straight-line winds. These winds can cause damage similar to that of a tornado, including downed trees, power lines, and structural damage to buildings. Lightning strikes obviously pose a significant hazard to both people and property. Direct strikes can cause injuries or fatalities, while indirect strikes can start fires and cause power outages. It is estimated that there are approximately 8.6 million lightning strikes per day worldwide. The Congo Basin in Central Africa experiences the highest frequency of lightning strikes, with over 150 flashes per square kilometre per year. The longest-lasting thunderstorm on record occurred in Oklahoma, USA in 2007. It lasted for over 17 hours and produced multiple tornadoes. The largest hailstone ever recorded in the United States fell in South Dakota in 2010. It measured 8 inches in diameter and weighed nearly 2 pounds. Thunderstorms are most common in tropical and subtropical regions, where warm, moist air is abundant. In the United States, Florida experiences the highest number of thunderstorms per year, with some areas seeing over 100 thunderstorm days annually. When thunder roars, go indoors, seek shelter inside a sturdy building or a vehicle during a thunderstorm. Avoid using electrical appliances and plumbing during a storm, as lightning can travel through electrical and plumbing systems. Stay away from windows and avoid taking shelter under trees or tall structures. Thunderstorms are awe-inspiring natural events that showcase the power and beauty of the atmosphere. Understanding the scientific mechanisms behind their formation and the weather patterns that lead to their development can help us better appreciate and prepare for these phenomena. From the mesmerizing display of lightning to the potential hazards they bring, thunderstorms are a reminder of the dynamic and ever-changing nature of our planet's weather. By staying informed and taking appropriate safety precautions, we can safely enjoy the spectacle of thunderstorms while minimizing the risks they pose. Thanks for watching and stay safe.